and welcome to this session for all those audience who are interested to know about Offgrid. Welcome to the Q&A session. We have both Ankur and Brindan who are the co-founders of the Offgrid Technologies. So, Ankur and Brindan, let's quickly go into like we have bunch of questions, very highly interesting questions that from
Mhm.
our audience. So let's start with our Q&A about like on the Offgrid Technologies. I will go with the first question from our audience. So, what inspired you to be part of this energy storage landscape, and what excites you the most? Is the question from the audience.
Okay, hi, hello everyone. Good afternoon. I hope every viewers are safe and sound. We are living in an unprecedented time. So, first of all, I would like to thank Cell E4 for this opportunity. I mean, the expertise and knowledge Shell E4 program has imparted upon us has been of great help and support. And not only on the technical side, but also on the business case front, we have made a step ahead from the day one we were selected on this program. So, if you are talking about inspiration, like right now we are dealing with a pandemic, and according to the leading scientists all over the world, this is just an undercard to the main event called climate change. And according to the avoiding the climate disaster is one of the biggest challenges that human face today. And although it is very hard to do, we believe it's possible, and that excites us to be a part of a solution. So to tackle the climate change, energy storage is regarded as the missing key puzzle for the renewable energy future. So yeah.
Thanks, Brendan. We have another very interesting question where we also have heard from your pitch about a novel battery technology. But there is a question about what is the main value proposition of your battery technology, and what is the competitive advantage of your technology as compared with the existing technologies that are available in the world?
Uh, like we mentioned, energy storage in theory at least is a enormous promising to the change we use energy, transport, dispatch, and consume. We need a reliable source of energy 24/7. And in order to do that, we've built a battery that is energy efficient, cost effective, and sustainable at the same time. And our idea was to develop a balance between all these parameters. And in order to achieve that, we innovated in three vectors at the same time and giving by a best overall performance. Like the first one is our eutactic solvent, which simply is a mixture of different certain salts in a certain ratio, which becomes a liquid at room temperature, and which does not require any additional solvents like water or organic solvents. And the second one is on the material side, where we use commonly available materials like zinc, manganese, and carbon. And in this case, we have innovated on synthesis protocol and materials. And the third one is obviously the how we make our batteries. In order to be scalable, it has to be in sync with existing manufacturers, how lithium-ion and lead-acid batteries are manufactured. And that's why we can use the same existing manufacturers to use that and make our batteries. And using this innovation, we have come with two variants. We call it zinc gel redox and zinc gel ion, targeting different segments of the market.
Thanks, Brendan. I mean, you touched upon like lithium ion and lead acid. So, what are those KPIs of your existing battery technology that you are developing over the existing battery technologies like lithium ion, lead acid, metal air, zinc air, and there are so many such kind of other battery technologies that so many startups are coming up, universities that are developing. So what are your KPIs? Something that you how you would like to compare over the existing battery technologies is the question from us.
Okay, I think the famous one right now is the lithium-ion batteries, of course, and they are high-performance batteries. But the problem is that it's very expensive. And the other hand, lead-acid batteries are cheaper, but very inefficient. And add to that, both of these battery technologies are toxic and harmful to the environment. And we at Offgrid are solving this in a very huge way. Like we are innovating in deep electrochemistry and using eco-friendly materials that are commonly available. Like if you're talking about lithium-ion batteries, the main factor is its cost. And that's why we are at one third the cost of lithium ion batteries. And if you are talking about energy efficiencies, we are on par with energy efficiency with lithium ion batteries, which is higher than 90%. And if you're comparing energy efficiencies with lead acid batteries or metal lead batteries, efficiencies is very low. Like zinc air batteries efficiency is around 60 to 70% at max. And same can be said for lead acid batteries. And while redox flow batteries like vanadium and zinc bromine are very promising and good, but again, the biggest drawback would be its cost. And that's what we have achieved in our technology, balancing every other aspects.
Right, right.
Yeah,
I have
just
a
to
quick
add to
for
what,
yeah. Sure.
yeah,
Go
just to
ahead.
add what Brindan is saying. Yeah, this is Ankur. I'm the CFO of the company and the co-founder of the company as well. So, just to add what Brindan is saying, that our company is essentially a deep tech company. We try to focus on radical innovations, and we are working with a common vision of developing sustainable energy storage for the future as well as for the present. And we are committed to build batteries that are cheaper and eco-friendly, uh, and what Brindan is saying, for example, for the lead acid battery and the lithium ion. So we have targeted that we can fit into the kind of applications wherein these two kind of technologies are existing, and we are innovating on the chemistries and the materials and the designs of the batteries which have their application in these kind of markets.
Thank you.
Yeah.
I think you both have touched a lot on the innovation, your current technology
Mhm.
development. So there's a follow-up question on like, what is the current stage of your technology, and when do you think to plan to enter the market?
Uh, as discussed earlier, we have right now developed two variants of Ginsel. The first one is Ginsel Redox. Its TRL level is fine. TRL is the technology readiness level, which is defined by NASA. And at that, Ginsel Redox lies at number 5. And for Ginsel Ion, we are at TRL level 4. So it's like a bit of a working to do. And how we are able to enter the market, I think Ankur will be able to get that answer properly,
Yeah.
right?
Sure. So, just to let our audience know that currently the entire energy storage market in the world is pegged at $59 billion. And because of the energy transition, the market is growing exponentially. It is poised to grow up till $130 billion within the next 10 years. So what we at the currently we are at the product testing stage. We are validating our product with the manufacturers and with our partners. And with this stage of development, we are expecting to have our pilots out in 2021, and then followed by our commercial launch in 2022. So we plan to enter the markets in this way so that we are able to transition our product easily with the kind of manufacturing facility available currently in the market. For example, our zinc gel redox, it can be manufactured on the similar lines at what lead acids are being manufactured. So uh, we plan to replace the existing facilities of the lead acid manufacturers with our kind of batteries, and we can launch those batteries in the market.
So,
So there's a question from Arpit from Shell. Interested to
Mhm.
know that who will be your target customer?
Yeah, our target customers would be the players which are in the energy value chain. For example, our applications range from uh, grid balancing, renewables, then microgrids, then mobile tower infrastructure, EV charging infrastructure, and last but not the least, the EV vehicle segment, especially the two-wheeler and three-wheeler. So we are planning to target the customers who are into this value chain, especially for the initially at the initial stage, we are targeting for the mobile tower applications as well as for the microgrid applications. So
okay.
currently we are in touch with the players who are the biggest utility in India and the biggest mobile infrastructure company in India. And these are the initial customers.
And to specify, I mean, the zinc gel redox is targeting the stationary application, while zinc gel ion is targeting the two-wheeler and three-wheeler mobility application.
Mhm.
Thanks. I mean, for those like who might have joined just now, I would also request Brindan and Ankur to give a quick
Mhm.
introduction about Offgrid. Then we have a lot of other Q&A that we could take post that introduction.
Um, hello,
Sure.
everyone. Thanks for joining. My
Yeah.
name is Brindan Tulachan, and I'm co-founder and CTO at Offgrid Energy Labs. We are a company that aims to be a world leader, innovator, and developer for sustainable energy future, driving disruption through research and development. Ankur?
Yeah. Hi. Hi. I'm Ankur Agarwal, co-founder of Offgrid Energy Labs. I am the CFO of the company and looking after the finance and governance piece of the for the company, along with forming strategy for the company as a whole. We really welcome our audience who have just joined us. Thanks.
I
Yeah,
mean,
Vishnu.
you talked about there's a question from Shell from Ashish. So, what are the kind of battery materials that you are using in your battery, and what is something so unique about them?
Uh, like the core value of our company is we believe in sustainability. And that's why while choosing the materials to go inside our batteries, all the materials that we have chosen is commonly available. It's a commodity material and really sustainable. That's why our batteries is very sustainable. I mean, it can be 100% recyclable at a large scale. And the main materials that we use in our battery is zinc, manganese, and carbon.
Thanks, Brendan. There's another question. I think you do have talked about some of the key performance indicators of the battery. So, there's another very
Mhm.
pointed question on the economics. It's a question from Shell from Ashish. What is the main pricing advantage of zinc cell batteries with respect to other competitors? Maybe like with other battery technologies that are available.
Yeah, Brendan, would you
What is
like
that
to take this
particular
question?
Yeah,
pricing? What is the pricing advantage?
like pricing advantage, like right now, if you're talking about price, lead acid is being sold at around 60 to 70 watt hour, 60 to $70 per kilowatt hour. And if you are talking about lithium ion batteries, it's around 150 to $250 per kilowatt. And newer technologies like vanadium flow batteries and zinc flow batteries can cost you up to around 400 to $500 per kilowatt hour. But right now we are targeting our batteries to lie within $100 per kilowatt hour.
Yeah, and to add to this thing, to what Brendan is saying, since we are a deep tech company, we are continuously evolving our product. We are doing so many experiments, testing, and through this, we actually target to bring down our cost to as low as so that it become one third of the lithium ion pricing and almost equivalent to the lead acid battery.
So, the question on your traction. So, what is your current traction and the kind of application areas that you have been working? And with whomever that you have worked, what is the experience of your customer who is working with you?
Yeah. So, since we are currently a pre-revenue startup and in the development stage, however, we have collaborated with few of the top companies, as what we indicated earlier as well. That these companies are the one of the biggest companies in the industry verticals, and we are working very closely with them, who would be potentially our industry partner and customers in future. Our experience is that, especially including the Shell, that we have been provided with great learning arena to understand the market dynamics, especially understanding the challenges when the products matures out of the lab and into the real world environment. We have tried to gain various data points, what would be the challenges in the real world situation, and plus of course we are working at various stages of applications. For example, we are working on um, uh, the grid balancing thing. We are working on the microgrid applications. We are also working on EV vehicle with our zinc ion batteries. So yes, so we are having a very good experience with our customer. Our customers, potential customers, are very good in a way that we find full potential in working with them in future, and we actually believe that we would be having a very long-lasting relationship with our potential customers and partners.
Thanks, thanks. I mean, a very interesting question from Deepak. What
Mhm.
do you think the key barriers for some of your plans that you are envisioning in the short term and long term?
We have cracked the chemistry. Now the barrier would be to crack the market. That's what I would say. I mean, to enter the market, we are still a very early stage startup, so we're still ready, enter the market. So I think that would be a barrier for now.
Yeah.
Very, it's a pure technology thing that you talked about. Thanks, thanks, Sundar. So there's an interesting follow-up question on that. So you talked about something in a barrier, something that you want to crack on the market. So what do you off-grid think as the future market that you are looking into, and what is the why are those future markets that you are thinking? Any reasoning around that?
Uh, like Ankur mentioned, there are markets
Mhm.
like grid balancing, EV charging infrastructure. These are up and coming markets. These are not available right now. So, in order to achieve that, there hasn't been a battery technology that can handle those kind of demand. Like in terms of grid balancing, you need higher rate capabilities batteries, which in our case, our batteries can handle. Like zinc gel redox batteries can handle charging up to 10, 10C, while discharging up to 5C kind of rate capabilities without deteriorating its life cycle and performance. So I think those are the markets we predict the future will play a critical role.
Yeah,
And
I
to
mean,
add to
there are
this thing,
several.
frankly speaking,
Go
yeah,
ahead,
frankly
Ankur.
speaking, the energy storage market, if we talk about, is still in the nascent stage. That means the solutions are not yet been fully foolproof. There are
Mhm.
have been challenges with implementing various technologies. For example, in case of a lithium ion, the challenges is that it requires ambient temperature. You have to supplement the batteries with the appropriate temperature. Otherwise, there are chances of it getting being fire or and plus, for example, in lead acid battery, uh, the life cycles is also a very big challenge. If we talk about the energy storage in grid balancing, or we talk about energy storage in renewable, wherein the entire project is for more than 20 years. So we cannot just keep on replacing battery after every 4 or 5 years. So we require a battery which can provide solution at least for 10 to 15 years minimum, with a and with a minimum cost. So there is a huge gap in the solutions available and in the applications, and this is what actually Offgrid is trying to solve. We are trying to solve to bring out a equitable balance between sustainability, a balance between the cost, and the balance between the efficiency with which we can deploy our solutions. Yeah. Is this what Vishnu you are asking, and the audience
Yeah,
is asking
right.
this question?
Yeah, yeah,
Okay.
yeah. Got that. I mean, there were again several questions on about
Mhm.
the patent. I mean, there were several questions like, do you have a patented on your technology? I mean, what is the current status of these patents? Would you like to answer on that?
Yeah. So we definitely, since we are a deep tech company, we are IP driven company. We have various IPs concerning patents and designs. Uh, we work unidirectionally to focus on creating and innovating various aspects of our technology. So in all, we have created almost more than 15 IPs. All of them are in various stages of the regulatory and validation processes. We are we are continuously evolving our technology, our tech, and of course, we are not only working on zinc gel technology, we are also working on couple of more technologies which we will be unveiling in near future. So many other more IPs are on our way.
Okay, great, great.
Yeah.
I maybe a quick refresh here for some of those people who might have joined a bit
Mhm.
late. I would suggest Offgrid to reintroduce a bit about your company so that will help like them understand briefly about your technology, your focus.
Sure. So we welcome the audience who have just joined us. Hi, this is Ankur Agarwal. I am the co-founder of Offgrid Energy Labs, and I am the CFO of the company. Offgrid is a deep tech company which is focused on energy storage innovations and is really poised to disrupt the energy storage market.
And hi, this is Brendan. I'm the co-founder and CTO at Offgrid Energy Labs. We at Offgrid are on a mission to develop a battery that are efficient, cost-effective, and sustainable.
Great. There was a let's again get back to some of the Q and A's that we have some other interesting questions.
Mhm.
Uh, so there is a question from Shell from Raunak where they would like to understand about who do you think that who are your local competitors and who are your global competitors in the zinc gel battery domain?
Uh, local local competitors are very hard to come by because big tech startups like ours are not there in the Indian market yet. But globally, I would say there are various companies working on zinc-based chemistries. Like there is Nant Energy, which is working on zinc air battery. There's Red Flow battery based out of Australia, which is a zinc bromine based flow battery. And there are various other companies like Primus Power, Zinc8, and US Energies, which would seem like our competitor.
Thanks, thanks. This is a question from Rajesh from Energon. So the question is about what are your business risks? What can fail for you if the market doesn't accept your technology the way that you anticipate?
I think being a tech developer, we have thought about it, and that's why the core material that we have designed has not only the use in our chemistry, but also can be used in other chemistry as well. Like for example, the electrolyte that we have developed, which is a deuterium based solvent, can be used in various applications like electroplating. It can be used in other batteries like zinc bromine batteries. It can also be used in zinc ion based supercapacitors. And it can also be used in battery techs like primary batteries that are used in household remote controls and toys. So those kind of strategy we have already developed. So I think it would be a good way moving ahead.
Yeah, great, great. I mean, there's a, I think this is a very good question, very interesting. A lot of people might have this in their mind about like comparison with the lithium ion. So there's a question about as lithium ion batteries get cheaper and cheaper over the years, where some of the market reports suggest that. So how do you see uh, as a battery company getting a new chemistry and zinc gel, compare yourself with the unit economics of lithium ion over the next few years?
Uh, Battery technology needs to be highly scalable. And I think that's where lithium ion lags behind. Like lithium ion utilizes materials like lithium, cobalt, which are rare, rare. And utilizing those kind of materials would be a very bottleneck for the uh, scalability. In our case, we are utilizing zinc and carbon. So it's readily available and highly scalable. And another aspect is that our manufacturability is almost on par with lead acid batteries. And if you're comparing manufacturability of lithium ion and lead acid batteries, lithium lead acid batteries are far superior and far easier to manufacture. So that's why our batteries would be highly scalable in terms of manufacturability as well. And
And
about the
to add
cost
to
of, yeah,
to add to what Brindan is saying is our batteries are we have the physical capability of a depth of discharge of almost 100%. So which actually contributes to high energy density. It also contributes to highly efficient charge discharge cycles, which overall helps us in scaling down the overall costs. So, for example, if we want to install a lead acid battery, which is almost at a 60% depth of discharge, so and R is almost 99-100% discharge depth of discharge. So would be requiring proportionately less number of batteries. Indirectly, it will help us in reducing our costs. So with this fundamental principle, with this physical science, we actually are targeting to have our cost to less than $100 per kilowatt hour.
Great, great.
Yeah.
I mean, you talked about like in your pitch about sustainability. So, what kind of sustainability challenges that you are solving over lithium ion and some other battery technologies that are already available? The reasoning is that we do hear a lot about the disposability issues that are associated with lithium ion lead acid. So, in your battery technology development, how are you tackling the same for the product development that you have already envisioned?
yeah, sustainability is like I said, it's a core value for us. I'll give you an example, like plastic. When plastic was invented, it was one of the breakthroughs of that time because of its usability and manufacturability. But right now, we are suffering its consequences. Plastic has become a problem for us. And similar would be the case for batteries as well, because battery is going to sit as at a core of a renewable energy future. And we want our batteries to be sustainable, recyclable. And if you're talking about lithium ion and lead acid batteries, those are very toxic. And if you're comparing with our batteries, all the components that we use are used in agricultural and animal feed industry. That's why making our batteries non-toxic and sustainable.
Great, understood. Understood. This is a very good question about something overall on the energy transition and the energy generation part. So, how can you can change the economics for energy access to distributed energy, and how do you think that your technology can help in achieving that in this midst of energy transition?
Yeah. So see, currently energy transition is actually happening in a way that earlier there used to be a very big power plant which used to generate power maybe through thermal or nuclear or whatever the source for hydel power project. But now of late, because of the good technologies available for the solar, the wind, and so these sources of energy. So these are quite distributed. You do not find actually power generation large amount of power generation at one single location. So the practical benefit of this distributed energy resources is that the customer gets greater reliability, the adequate power quality, including potential to actually mitigate the overloaded transmission lines. Then, of course, since the consumers can have their own power plant installed in their premises, whether it be it a residential or it be a commercial or at a very large industrial scale, you have somewhat control over the purchase price of the electrons, the fluctuations you can actually monitor, and plus you can have control over the energy stability, and overall it provides the stability to the grid. So batteries play a very important role in actually linking the demand and supply of the power in the DER value chain. For example, if a particular power is being generated at a particular place, but the supply is there, but the consumption is not there. So the battery can help us in storing the power at there and then, and it can be utilized at a subsequent time. For example, in case of a solar, we get power generated during the day, which can be utilized during the night. And even with a small use case of a microgrid or even a mini grids, so this power can be generated through one single source and can be distributed over a cluster of consumers. So this way, the distributed energy system can be a reality in a big way. Uh, the batteries can play a very pivotal role in linking the the generation and the consumption of the power, and it can be really a game changer in the entire ecosystem.
There's a question from Nero, very pointed question is like, how much time one can charge the battery if it is of like zinc cell as compared to the anything that is available in the market. Maybe the way to expand is if it is for mobility related application, what do you think as the charging time? As you have mentioned about fast charging.
Yeah, like if you're comparing with lithium ion batteries generally take an hour to 3 hours of charging time. And if you are talking about lead acid batteries, it would take you around 8 to 12 hours of charging time. But in our case, our batteries can be charged within 15 minutes because of our unique chemistry, we can charge our batteries with constant voltage rather than constant current, and that's a complete game changer in uh, this energy storage.
Yeah, I mean, there's a very interesting question about Tesla. I mean, how could we miss about Tesla when you're talking anything about the EV or the battery? So, the question from Jishu Mohan from Shell is that, can you compare your product with Tesla battery, and how can you convince him to buy if it is a zinc gel as compared to the Tesla battery? So, which capacity batteries that will be producing more and why?
Uh, I think the honest answer would be we are not competing with Tesla because Tesla batteries are high performance batteries whose energy density is around 250 watt hour per kilogram. And we are basically focusing towards stationary based application, uh, and our application is suited towards it. So I think it's a completely different market segment.
Oh, great, great.
Yeah.
So, I mean, just like again, just cautious that if there are some audience who might have joined few minutes later, if someone have joined like few minutes before,
Mhm.
let's have like a quick overview about what Offgrid is all about.
Hello, everyone. My name is Brendan Clutton, and I'm a co-founder and CTO at Offgrid Energy Labs. Our company aims to be a world leader in innovator and developer for sustainable energy storage, driving impact through research and development.
Yeah, hello everyone. This is Ankur Agarwal. I'm the co-founder of Offgrid Energy Labs, and I'm the CFO of the company. We welcome our audience who have just joined us. It's we are really enjoying this conversation.
Yeah, thanks, Ankur and Baldev. There is a question again from Shell, from Balaji Srinivasan. What other new battery technologies that are there in the development around the world, and what are off-grid key differentiators?
Um, like there are battery techs like we discussed, zinc air batteries, aluminum air batteries, vanadium redox flow batteries that are up and coming. And there are other battery technologies like uh, molten salt batteries. But if you are comparing those batteries with ours is a very efficient battery. Our efficiency can reach up to 90%, which is almost on par with lithium ion batteries. And if you are talking about zinc air, its efficiency, the highest efficiency it can achieve is around 60 to 70%. And if you're talking about vanadium flow battery utilizes vanadium as a uh, redox component, but in our case, we utilize zinc and manganese. And if you compare the price between these two, there's a humongous difference, the price parity between these two materials. So yeah.
Great. I mean, there's a very maybe very interesting question overall for the research wise. So there are so many chemistries that have been promised at the lab stage, but these chemistries start failing when they move to the commercial stages once it goes to the de-risking. How
Mhm.
do you rate yourself on these parameters of becoming more commercially viable?
Yes, I think most of the technologies fail. Most of the people have questioned us about this, and our answer is that the scalability becomes an issue when you're taking from lab scale to a commercial level. And if you're designing your batteries in such a way that you have to completely redesign and retool manufacturability in order to make your batteries, then it becomes a humongous problem. But in our case, we utilize lead acid manufacturing capabilities. We use same process to manufacture our batteries. And I think that would bring a very valuable chain in order for scalability issues. That's why I think we believe we can achieve it.
And plus, of course, we are also running pilots currently, and the results are very promising. We have with a very good laboratory facility from Shell, and plus we are also incubated out of IIT Kanpur, so we have using various facilities from IIT Kanpur as well for testing our product. So along with the partners, the feedback which we are getting currently from industry partners, so that's very quite promising, and we believe that our batteries won't face that kind of a situation wherein we have to reinvent the wheel at a later stage. So we are quite confident in our technology, theoretically as well as practically.
True.
You talked about the pilots that you're currently like doing it.
Mhm.
So, what do you think as the target application areas that you are focusing on the short term and the target application areas in the long term?
Yeah, so see, currently we are working on a couple of applications. As I've already said, that our kind of batteries. So just to start with that, we are having two kind of batteries which we have innovated currently. One is the zinc gel ion, and one is the zinc gel redox. So zinc gel redox finds its application in stationary market, for example, grid balancing, renewables, tower infrastructure, EV charging. Whereas the zinc gel ion, it finds its application in two-wheeler and three-wheeler, commercial two-wheeler and three-wheeler electric vehicles. So currently we are doing our pilots for the microgrids and tower infrastructure, and plus we are also working for developing for EV charging infrastructure. So these are the short-term applications. For the long-term, also we are targeting for two-wheeler and three-wheeler applications, which we expect to commence within next 6 months or 9 months. And for our long-term applications, yes, we look for the entire spectrum of the value chain because our kind of batteries are such that basis the application, we can tune some chemistry and that we can get our batteries fine-tuned to the application for which we are using. Yes.
Another bit of visionary related question because as you talked
Mhm.
about like EVs and two wheelers,
Mhm.
what do you have to say about the achievability of reaching the global targets of certain number of electric vehicles by 2030?
Mhm. See, many organizations, especially the government organizations and even the organizations, multinational organizations working in private sector, everybody has understood how the climate is changing and what are the serious risks for the sustainability of the entire planet. And there have been many impetus from all sectors of whether it's from the government or from the industry and even from the retail consumers. So everybody is targeting to transition themselves into a more greener energy, into a more sustainable energy. And we believe that with the efforts of everybody, the ecosystem would be well in place, and we would be able to achieve 2030 target.
Yes, I think
Yeah,
it is hard, but I think it's doable as well.
it's doable. Yes.
Uh, yeah, Ankur, and when you talked about multiple application areas, right from the load balancing, distributed energy, EV vehicles. So,
Mhm.
what is your business model? How would like to you would like to see Offgrid? Is it more of a technology company, or are you aiming towards moving as a battery company?
See, we want to first of all we want to remain a tech company only. We want to focus on innovations. We want to focus on new kind of chemistries, new kind of batteries, and our aim would remain to be a purely innovating company. We would actually not might not be interested in manufacturing ourselves the batteries. We would rather outsource or maybe license this to an existing or a large manufacturer. As we have already said, that we are partnering with leading energy companies to validate and validate our technology. So we are thinking of licensing our technology for manufacturing and deployment in various applications. Plus, we also believe that our patented material can be used by other battery technologies like flow batteries, supercapacitors, or maybe zinc manganese oxide batteries. They can use our patented materials. So we are also thinking of licensing those materials so that they can develop their own chemistry. Plus, in addition to this thing, we have built our designs for the EV charging infrastructure, which we believe are very efficient. They are and they can be deployed with great ease of transition. So we also intend to license these designs to EV manufacturers or the people who are working in EV charging infrastructure.
Yeah.
So
Yeah.
there's a very good, maybe like on the level follow-up question on the business model from Balaji
Mhm,
from Srinivasan. So
mhm,
he mentioned that like you are mentioning about your revenue models or the business models is going to be more about licensing the technology and leveraging the existing manufacturing capacity.
mhm.
Uh, the question is about what other revenue models like you as a company have evaluated before you thought about this approach of licensing the technology, and have you seen any distinct advantages in this approach with the other revenue models of becoming like a battery company or maybe other way of generating revenue with this technology?
See, frankly speaking, we want to remain focused on development and innovation. We do not want to get distracted with the routine manufacturing processes or the logistics because we are sure that the kind of facilities we have globally, so our technology can be easily transitioned into their manufacturing capacities. They have the capabilities, all the entire supply chain. They are the masters of the supply chain, so we do not want to compete in that arena. We just want to compete in what we are capable of doing. And we want to focus on delivering new and new products, continuing evolving our existing product line and thinking for the future. So this is what actually we envisage for our company as a whole.
Yeah, I think you should stick what you're good at. I think, and we are
Yeah,
good at
correct.
developing and innovating, and
Yeah.
we will always stick with that. So,
Very, very inspiring. I like that statement, like need to stick what we are good at. Where you have self-evaluated your core capabilities well. Very good to know. I think there's just like a last statement here from Rainis from a Catalico SIA, where they say that Rainis is from Catalico. They are the producers of high surface area zinc oxide, where they believe that the surface area could contribute in enhancing the battery performance. They would like to connect to you to evaluate the benefits of increasing the surface area of the zinc in junction. Sure, Rainis, we'll help you to connect with Offgrid post this call. I think just in the interest of time, I'll request all the audience if you have any other questions, if you would like to further connect to Offgrid, please drop your email or your contact details or any other questions that you have. We're happy to
Mhm.
provide those answers to you in offline. It has been a great session. Thanks Ankur and thanks Brindan for providing such an
Yeah.
insight and really wish you all the best in the journey of making this technology successful and also help in like decarbonizing the world.
Sure.
Thank you, Vishnu, and thank you,
It's a
Akshay.
really pleasure to have a discussion, and it was really interesting. And we last but not least, we really want to thank Shell E4 for providing us such a platform and for hand holding us for at least for the last 6 7 months, especially during the pandemic. The team has been super supportive, and we really thank the entire team for guiding us, for taking our product to the next level. And we are really looking forward for a very good future and partnership with Shell.
Yes.
Thank you. Wish you the same. Yeah.
Okay.
Thank you so much.
Thanks.
Thanks.
Thank you,
Thank you,
guys.
Vishnu. Thanks.